Hello everyone, welcome to ChemWorld. We are going to present you some basic concepts in chemistry and we will start with significant figures. Significant figures represent a fundamental concept in scientific measurements that every chemistry student must master. For chemistry majors, you will be studying significant figures and then whenever you do calculations in chemistry, you will use these significant figures. They are not just an academic exercise, it is an essential skill that impacts all laboratory work. From basic titration calculations to advanced spectroscopy, proper application of significant figures ensures the integrity of your scientific results. Let's see what are significant figures. Significant figures are the digits in a number that carry meaning about its precision. They are important in science and engineering because they reflect the accuracy of measurements and calculations. And also, significant figures communicate the certainty of each measured value, establishing boundaries for what we know versus what we estimate. Unlike decimal places, which simply indicate position, significant figures tell us about the quality of our measurements and the reliability of our instruments. When you are learning significant figures, there are some rules you need to know. The first one is non-zero digits. All non-zero digits are always significant. As an example, in the measurement of 7.843 grams, all four digits including 7, 8, 4 and 3 are significant because each carries meaningful information about the measurement. Second rule is zeros between non-zeros. Zeros located between the non-zero digits are always significant. Here, 6.08 milliliter measurement has three significant figures including 6, 0 and 8 because 0 is needed to correctly position the 8 in its decimal place. Leading versus tailing zeros. Leading zeros before non-zero digits serve as placeholders and are never significant. However, tailing zeros after a decimal point are always significant as they indicate precision. The last one is whole numbers. For whole numbers, tailing zeros are ambiguous without scientific notation. The number 1000 could have 1, 2, 3 or 4 significant figures depending on the intended precision. Why are significant figures important? When you measure something, you can never be 100% exact. Significant figures help show how precision a measurement is, avoid giving false precision in calculations, and significant figures help to communicate uncertainty in scientific work. Let's see some examples. For the first rule, all non-zero digits are significant. This is an example. 3281. This one has 4 significant figures. Here, all are non-zero digits, so you have to take 3, 2, 8 and 1 as significant. According to the second rule, zeros between non-zero digits, they are significant. These zeros are really important and this is where the student get confused. However, 8901 has 4 significant figures because the zero here is between two non-zero digits. Therefore, you count 8, 9, this 0 and 1 as your significant figures. When you write a number using a decimal place, there is a reason for that. So when you are counting significant figures, 2 is significant, this 0 is significant as well as the 0 after decimal place is significant. Therefore, 20.0 has 3 significant figures. However, if you use zeros, 0.00721. These three zeros in front of non-zero digit, these are not significant. They are only placeholders. Therefore, you have only 3 significant figures in this number. The other one is, if you write 100, this has only one sig fig. But if you mention 100.0, after decimal place, you have to count this 0 as significant. Therefore, your number has 1, 2, 3, 4 significant figures. As we discussed earlier, when you see a number 1000 here, depending on whether it's in the scientific notation, we can put different number of significant figures. So this number has only one sig fig. However, if you put this as 1.000 times 10 to the power 3, still the value is 1000 and you have 4 significant figures. 1, 2, 3 and 4. You can also write this as 1.00 10 to the power 3 in scientific notation. However, now you have 1 is significant, these two zeros are significant, so you have only 3 significant figures. You can also write this number as 1.0 times 10 to the power 3, where you have only 1 and 2 significant figures. Calculations with significant figures. This is very important because chemistry students, when you learn significant figures in your first chapter, you will use your significant figures for your all calculations. There are some rules you need to follow. Let's take addition and subtraction. Addition and subtraction has a one rule. Your answer should be rounded to the least number of decimal places. For addition and subtraction, you check the numbers you are given and count the decimal places you have and then get the answer and round it to the least number of decimal places. As an example given here, 12.54 grams has 2 decimal places, 8.7 has 1 decimal place. Your answer is 21.2 because you rounded off your number to the 10th place where you have 1 decimal place, because 8.7, the given number, has only 1 decimal place. That's the least number. When we think about multiplication and division, there is a one rule for that. For multiplication and division, your answer should have the same number of figures as the value with the fewest significant figures. 12.3 centimeters multiplied by 5.123 grams gives you 63.0, where you have 3 significant figures. You can see in this answer you have 3 significant figures. 6, 3 and 0, they are significant. When you look at the given numbers, 12.3, here you have 3 significant figures, and here 5.123 has 4 significant figures. So the least number of significant figures are 3. Therefore, your answer should contain 3 significant figures. When you do calculations in order to obtain the correct significant figures, either addition and subtraction or multiplication and division, you have to round off your numbers. Or sometimes you have to add zeros in order to obtain the correct significant figures. There are some special cases. Logarithms and exponential functions follow different rules. The number of decimal places in the result of a logarithm equals the number of significant figures in the original number. Let's see some examples for multiplication and division. For multiplication and division, 4.56 multiplied by 1.4. First, look at how many significant figures are given in the numbers. So here you have 3 significant figures and 1.4 has only 2 significant figures. According to the rule, when you do multiplication or division, your answer should have the same number of significant figures as the value with the fewest significant figures. So the fewest significant figures are the 2 significant figures. So you do the multiplication and get the answer. You can see the answer is 6.38. In this number, you have 3 significant figures. However, with the correct significant figures, you need only 2 sig figs. Therefore, you round off this number, and 6.38, when you round off, your number gives you 6.4 as the value. Therefore, your correct answer is 6.24 with 2 significant figures. Let's do another example for addition and subtraction. You have given 12.11 plus 18.0. So let's see what are the decimal places, because the rule for addition or subtraction, you look at the decimal places of your given numbers and take the least number of decimal places to your answer. Here you have 1 and 2 decimal places, and here you have only 1 decimal place. Therefore, when you do the math here, you will get 30.11 where you have 2 decimal places, but our correct answer should contain only 1 decimal place. Therefore, when you round off 30.11, you will get answer as 30.1 with 1 decimal place. Scientific notation and significant figures. Scientific notation is a way of writing very large or very small numbers using powers of 10. It's commonly used in science and engineering to make numbers easier to read and work with. This is the basic format we use to write in scientific notation, where the n is the coefficient and it's between 1 and 10. And also you can include decimal places. Lowercase n is an integer exponent. Scientific notation, this format eliminates ambiguity in tailing zeros for whole numbers, making significant figures explicitly clear. Clear precision. All digits in coefficient n are significant. As an example, 3.00 10 to the power 3 has 3 significant figures because 3.00 here has 3 significant figures. While 3 times 10 to the 3, in this number you have only 3 non-zero digits, so you have only 1 significant figure. Using scientific notation in lab reports ensures that readers understand the exact precision of measurements. Let's see how you convert numbers to scientific notation. First, move the decimal so that you have 1 digit before the decimal point. Second, count how many places you moved in. If you moved left, the exponent is positive. As an example, if you have this number 45,000, if you want to write this in scientific notation, you move decimal places in 4 to left. So 1, 2, 3 and 4. So you are moving to left. You write your coefficient 4.5. Since you move 4 places, it's 10 to the power 4. And since you are moving to left, it is positive. If you move to right, the exponent is negative. As an example, 0.0063, if you want to write this in scientific notation, move decimal 3 places right. 1, 2, 3. Now you are moving to right. Therefore, your coefficient is 6.3. It is 10 to the power negative 3. This is negative because you are moving to right. Using with significant figures, scientific notation helps to show significant figures clearly. Like if you have 6.0 10 to the power 3, this one has only 2 significant figures. When you write 6.00 10 to the power 3, now you have 3 significant figures. As I mentioned earlier, significant figures are very important in science and engineering. These are some practical applications in chemistry: titration analysis, spectroscopy, and publication standards. When you do a titration, you take the burette reading to do your calculations. Therefore, burette readings must be recorded with the proper number of significant figures. Even in advanced spectroscopy techniques, wavelength precision and absorbance or transmittance value must be reported with correct significant figures. The American Chemical Society and Royal Society of Chemistry maintain strict guidelines for significant figures. Therefore, when you are submitting a manuscript, you have to be very careful about your significant figures of the calculations. These are best practices and tools. First one, carry extra digit. During multi-step calculation, maintain at least one extra digit beyond the required significant figures. Only round the final answer to avoid cumulative rounding errors. This practice helps preserve accuracy throughout complex problem solving. Utilize digital tools. Several software options including specialized calculators, Excel formulas, and chemistry-specific applications can automatically track significant figures throughout your calculations. Learn how to use these tools early in your chemistry career to build good habits and avoid common mistakes. Document properly. In laboratory notebooks, always record raw data with all digits from the measuring device. Then apply your significant figure rules in calculations. Include uncertainty values when it is possible. Proper documentation creates reproducible science and builds your reputation for experimental rigors. Thank you.